Hi guys, let's do maximum twin sum of a linked list. So in a linked list of size n, where n is even, the ith node, which is 0 index, of the linked list is known as the twin of the n minus 1 minus ith node if 0 is, okay, whatever. So for example, if n equals 4, then node 0 is the twin of node 3 and node 1 is the twin of node 2. These are the only nodes with twins for n equals 4. The twin sum is defined as the sum of a node and its twin. Given the head of a linked list with even length, return the maximum twin sum of the linked list. So I feel like the explanation of the problem is kind of confusing, and it would probably make more sense if we just look at the examples. So in example 1, basically we want to get the sum of like for the first node and the last node, and the second node and second to last node, and so on if there were more in the middle. And we want to get the maximum of each of these sums and return that. So in this example, where head is pointing at this linked list, 0 is the twin of 3 and 1 is the twin of 2. So each of these, like 5 plus 1 is 6 and 4 plus 2 is 6. So each of these have a sum of 6, and there's no other nodes with twins. So the maximum twin sum of this linked list is 6. And so we return 6. So in example 2, our head points at this linked list and we output 7 because the nodes with twins in this linked list is 0 and 3, which has a sum of 7, and 1 and 2, which has a sum of 4. So the max of 7 and 4 is 7, so we return 7. And then for this last example, our head points at this linked list and we output 100,001 because there's only one twin set of nodes here, which is 0 and 1, and they have a sum of 100,001, and so we just return that number. So for this problem, we are going to want to do a few steps here. So first step is we are going to want to, and let me actually type out our example so it's clear. So if our head is pointing at 5 to 4 to 2 to 1. Okay, and then we are going to want to do our little 2-pointer approach again here. So if we have our slow and our fast that are both at 5, and then we just want to, basically when the fast pointer reaches the end of the linked list, our slow pointer is going to be in the middle because fast is moving 2 at a time, slow is moving 1 at a time. So basically, after one iteration, fast will be at 2, slow will be at 4. Slow and fast, and then the next iteration, slow will be at 2, fast will be at 0. So, slow, and then fast is at 0. There's nothing here. So I guess we could say it like that, right? And then, so this is the middle of our linked list. And then we want to reverse the second half of the linked list. So slow is pointing at the node in which we want to start our reversal now, right? From here on, we want to reverse this. So that way, once we reverse it, like if we have this, and just ignore this for right now, then that way we can start slow, or start one of our pointers at 5, start one of our pointers at 1, and just add them up as we go and increment each of them by 1, and then just have a running maximum as we go that keeps track of the max sum, right? So that's basically what we're going to do. So, yeah, let's just get started. So we're going to first want to initialize our slow pointer and our fast pointer. And then we're going to just do our 2-pointer. We're just going to do our 2-pointer, basically. So if you haven't seen that video, I would watch that video first, because that's basically just this part. And then, so this is going to get us to here. And let me move this back to how it was. Yeah, so that's going to get us here. And then once we have that, then we're going to want to do the reversal. So once we reverse it, so we want slow to be pointing at this 1 instead, because we still want slow in the middle. We want one of them to be pointed at the middle of the linked list and the other one to be at the beginning when we do the side, like when we move them like side by side, right? So we're gonna want to assign slow to the new middle node after we reverse this. So I'll just create a private method to reverse, but we're gonna pass in slow. So because we're gonna start from here for the reversal. So let's do our private method now. So private list node reverse, and then we're gonna take in a list node head. And then if you haven't seen my video on how to reverse a linked list, I would watch that first too, because this part also kind of is just that. So we are going to want to have a previous node as null, and we are going to want to have a dummy node that starts at our head, which in this case is 2, because we're passing in slow. And then while our node is not null, we're going to reverse. So we need to keep track of the next node. And then we're going to assign our node's pointer to the previous node, which is, so for our reversal, we basically have null pointed at 2, pointed at 1, like that. And so our previous is null, our current one is 2. So we're gonna just wanna move the reverse that basically. So 2 is pointed at null now. So node.next is prev. And then we're just gonna set prev to our node. And then our node, we will move to our next node. So, and then we're just gonna keep repeating this until the whole thing is reversed like that. And then when we're done with our reversal, then basically our previous node will be pointed at 1, and our actual like node that we were iterating through will be pointed at null. So we're gonna want to return prev. So because that's the node that we want our slow pointer to be pointed at. Remember when we do the reversal like that? So yeah, so we'll return 1, and then we're not actually reattaching anything here though, we're just reassigning slow to 1. So we basically now have 2 separate linked lists where we have this 5 pointed at 4 and we have 1 pointed at 2. So this is our new linked list basically. We like split it up into 2, and then we have slow pointed at 1, sorry. Right, because we just reassigned that. And then our fast was still originally pointed at null. So after our reversal, we're gonna want to reassign fast to head because head is still pointed at 5. So that way we'll have that basically, and I'll space that out so you can see better. But yeah, so then once we have this, then we just need to iterate both of them through each of their linked lists and calculate the running sum. So we're just gonna want a variable for the maximum sum, and we'll start that at 0. And then while our fast is not null and slow is not null, then we're just gonna calculate the maximum sum. So between our current max and the sum of these 2 values, so fast.val plus slow.val. And then we're just gonna want, after we find the sum, then we just want to increment each of these to their next value. So slow is slow.next, fast is fast.next. And then we'll do that until they're both null, and then we'll exit the loop. And then we just return our max sum. So let's run that. Okay, and then for this problem, let me delete that now. Our time complexity is, sorry, it's kind of hard to see because it's so long. O of n, where n is the number of nodes in our linked list. Okay, let's take a closer look here because there's a lot going on in here. So in our actual algorithm, right, so first we looped through the entire linked list with our slow and fast pointer to find where the middle was. So that's O of n, which is this while loop here. And then we reversed the second half of the linked list, which is here and in this private method. And here, that is also basically O of n, because, well, technically n over 2, but then we just make it O of n, right? Because we iterate through the entire second half of the linked list to perform the reversal. So that's basically O of n. And then after that, then we just iterated the fast and slow pointer through each of the respective linked lists kind of side by side to calculate the sum, which we do here. And that is also basically O of n over 2, which we just simplified to O of n. Or actually, no, that is just O of n, because we still loop through the entire, like every single node in the list, we're just doing it side by side, like simultaneously. So that's still O of n. But yeah, so then all of this just simplifies down to O of n, because each one is O of n. And then since we're adding them, it's basically O of 3n, which is O of n. And then our space complexity is constant because we just have our slow and fast pointer here, which we, and our maximum, but these are all like just variables basically. We don't have any data structures going on. So that's it for this problem. Thank you guys for watching, and let me know what problem I should do next. Bye.